Good day, students. You're welcome back again to our lecture series, online lecture series. The last time we met, we talked about a lot of things. We talked about the internet, computer networks, and how they form or become part of the internet. We talked about concepts like the HTTP, hypertext, hyperlinks, protocols on the internet, and why the internet is different from the World Wide Web. Today, we'll be talking about some key concepts again under this course, computer internet programming or cloud computing. And the topics we're going to be talking about today are internet architecture, TCP/IP, IP addresses, domain names, and web systems. So join me as we go on a ride today. Let us begin with internet architecture. Internet architecture. From the word architecture, I want to believe you are aware that architecture can also mean structure. It can also mean the configuration or the framework. So by that, we understand that the architecture of the internet, or let me say the internet architecture, can also mean the structure of the internet. In straight words, in simple terms, internet architecture or the structure of the architecture followed a layered approach. And the internet architecture is described in its name. When you look at the term internet, it means inter-networking. That means connecting one network to another or connecting two or more networks together. It's a compound word, it's a compound statement, inter-networking, and shortened into the word internet. And the architecture of the internet, like I told you, is a layered approach. It depicts how one network communicates or interconnects with another network, and these two networks may be different, significantly different in their technical design, in their topologies, in software, or even in hardware. They may be different, yet they should still be able to communicate seamlessly, effortlessly, because the architecture of the internet provides for that interconnection between these two or more networks. Straight to the point, the internet network is known as TCP/IP. It means TCP/IP. These are two, TCP and IP are two very standard protocols on the internet. We talked about protocol in the previous class. You can refer to that video to refresh what protocols are. These two protocols of the internet forms its architecture, TCP/IP, and like I told you, it follow layered approach. And talking about layered approach, we must talk about something that is very, very key. Before we come into TCP/IP, we must look at what we call the OSI layered reference model. the OSI reference model, developed by the ISO, the International Standard Organization, to encourage systems interconnections. And that is what gives rise to these protocols of the internet following a layered approach. Layered approach follow a simple logic of pass it on. There are layers in communication systems that data must go from one layer to another, from one layer to another, in order from the source to the destination. And we'll quickly talk about the ISO OSI reference model. It follows 7 layers. It has 7 layers. And I'll quickly run through the 7 layers. We have layers 1 to layer 7. Now the layer 7, one thing I must tell you about this is that the layers are structured and they are standard. You cannot mix one layer for another. So layer 1, which is the lowest of the layer, or the one at the bottom of the layer, is known as the physical layer. The physical layer. This layer is what helps us to convey bit streams. The actual transmission of data in electrical impulse or radio signals. This layer is what is responsible for movement of data from one device into another device through the physical cables or the wireless systems through radio waves. You must have been hearing about 5G and the controversy that has enveloped the world in this pandemic period. And then you begin to understand what 5G means. So physical layer help us to receive or send data through cables. For example, we have the Ethernet cables that we use to connect one system to another. And through that cables, streams of bits run through the cable, carrying information from one device to another. Above the physical layer is the data link layer. Actually, the data link layer is subdivided into 2 different layers. We have the MAC, that is the media access control, which actually controls how a computer on a network gain access to the data and when it gets permission to transmit the data. Now, this is more like a traffic control. When there are a lot of devices trying to use the channel, this media access control ensures that each device gets its fair share of the channel and at the right time and for how long. So it determines who transmits first and who transmits next, for how long and when we get to transmit, so that we don't just every device don't just dump data onto the single channel, and then we have what we call traffic that slows down the connection or the transmission and can even lead to data loss or error. While the other sublayer of the data link is known as the LLC is responsible. The LLC means, by the way, logical link control. It is responsible for synchronization. Synchronization means flow control, meaning that between sender and receiver, we must synchronize so that we don't oversend or underreceive. A fast sender does not overboard, does not burden or bore a slow receiver with too much of data. So both of them must work hand in hand to receive data. And of course, it is also above the data link layer is the network layer. The network layer. It is known as the layer 3, and this is where a lot of things happen. Most of the things that happens about data routing and those stuff happen here. So part of the things that happen on this network layer, and the most very common one, is IP addressing. IP addressing happens here. Also, another very common one is routing. That means moving data from node to node, especially between two different networks. Network layer also ensures inter-networking. That means connecting of two networks through routers. Congestion control and packet sequencing happens also in this layer. So this layer is very, very important. It's is a very key layer, the layer 3. Routing, switching. So the switch and the router operates here because they are layer 3, especially the router is a layer 3 device. Above the transport layer, above the network layer is the transport layer, which is known as layer 4, and it provides transparent transfer of data between end systems. It is responsible for end-to-end error recovery and flow control to make sure that the entire data that was sent moved and gets to its destination without any parts being lost. Above the transport layer is the session layer, and this layer is responsible for establishment and termination of interconnection session. So when a device want to communicate or transmit or make a dialogue with another system, a session must be established. A session must be established in order for this conversation to take place. And this session layer sets up, coordinates, terminates conversations between two communicating devices. Above the session layer is the presentation layer, the layer 6, and this is responsible for encryption of data, transmitting data in a secured manner, ensuring that data is being transformed from the form the application can understand to the form or the format that can be transmitted over the network, and vice versa. So the presentation layer is also known as or sometimes called the syntax layer, and the reason is obvious. It ensures that data is in the proper format. The last layer, or the topmost layer, is the application layer. the seventh layer, the topmost layer. And this is the layer where internet or network sensitive applications reside. Here, this is the layer that is closest to the users, and it presents data to in the form that humans can understand and interact with. So it's more or less the interface for the user. Services provided by this layer include file transfers, email, and the rest of them. So before I move on, let me quickly give you a simple manner of remembering the 7 layers of the OSI model in the proper arrangement from layer 7 to layer 1. And that is a simple way of remembering it. We say all people seem to need data processing. So the first letter of all of these words forms the 7 layer, when we have all to mean application, people to mean presentation, session to mean SIM, or rather SIM to mean session, sorry about that, and to mean transport, need to mean network, data means data link, and processing means a physical layer. And by the way, that idea of remembering the ISO model was given by Imran Rafan as a form of reference to him. Now, here are some of the key things we must remember about this OSI reference model. Is that every layer beginning from layer 7 works on a data and pass it on to the next layer. So meaning that on the sending side, data begins from the application layer, moves to the presentation layer, to the session layer, down to the transport layer, to the network, data link, and then physical layer, through which it then gets to the receiving side, that receives it through its physical layer, pass it on to data link, and up until it gets back to the application layer where the user can see it and relate with it and understand the data. So the top 4 layers of the OSI model are known as end-to-end because they operate on end devices, while the lower 3 layers are peer-to-peer because in between them there could be more than 1 or 2 or more other in between devices that the data may encounter before getting to its destination. So that is the OSI reference model. Now the internet model, that is the architecture that we have talked about of the internet, the model, the layered approach of the internet is known, as I have mentioned before, as the TCPIP model. We will get to that quickly, but before then, you can refer to course materials to get better understanding of what this layer actually do, because they have their specific functions. They have their specific functions and they have protocols that works or that operates on each of the layer. And so I'm going to task you to finally on internet architecture, we'll talk about the TCPIP model. And this is another layer that is operational on the internet, and is significantly different though similar to the OSI model as explained before. So as against 7 layers, the TCP/IP has 5 layers, namely application layer, transport layer, network layer, data link layer, and physical layer. Although this is a little bit subjective, in the sense that in some texts you find them using 4 layers, which I would actually prefer 4 layers, and that is the application, transport, internetworking, and network layer. So these are the layers of the TCP/IP model, and then in the course material that I'll be sending across, you find the functions of these layers. Thank you very much. That is the lecture for internet architecture. Subsequent lectures will be going over to other parts of the lecture, like the IP addressing, domain names, and web systems. So today in this lecture we have talked about the architecture of the internet. We have talked about the ISO OSI reference model and its approach and its layers, and of course we've talked about the TCP/IP model. So should you have questions, I want to believe we can tackle questions at the interactive session that we will hold on the WhatsApp group, or better still, you can chat me privately to get answers to your questions, or you can simply drop your questions in the comment sections of the video, where I will respond to them. And when we meet in the physical class, we can also go ahead to tackle questions. So make sure you like this video, comment on it, share, and subscribe. Thank you once again.